All right. How you doing, guys? A lot of sessions today, a lot of knowledge. I've seen some impressive stuff. Already want to get my hands dirty. All right, so today I'm going to talk about the SQL code and continuously deploying it to your environments. Any DBAs out there? Like database guys? No? OK, so I'm probably the only one in the conference, actually. I'm not sure. I saw some hands in the air in the meetings, in the global meetings, but oh well. Anyways, I'm a DBA for a long time now, more than 10 years. I work at X Matters in Canada. I'm a major contributor to one of the very popular database-related PowerShell modules called DBA Tools. I'm automation guy and actually a big Jenkins fan. So I definitely will be showing you some Jenkins magic at the end of the presentation. And what I'm going to tell you about today is how you would put your SQL code or the SQL code that are your developers developing into a pipeline that will automatically deploy this stuff for you onto your environments. How it is different from the application perspective. So let's say you have an application that deploys new versions every time. And the biggest difference with database, you just can't tear it down. So application, you tore it down, you created a new instance, you replace the files, and it works. Database, you replace the files, and you're fired. And that's probably the biggest difference. In the database world, we tend to run things continuously and in small changes. We are kind of taking the current state of the database and we apply modifications to it instead of replacing the whole damn thing. So now, when it comes to continuously deploying the code, apparently we need to apply the same approach. And what people came up with is basically two different deployment scenarios. I like to refer to them as model-based deployments and script-based deployments. So models is your golden copy of the database. And when you want to deploy a certain state of the database, you take the golden copy, you compare your target database with this golden copy, and then you see, well, what's the difference? OK, so there is one table missing, one column missing here. There is a different data type. So now we dynamically generate the migrations, how to bring the database from state A to database state B. And that's exactly how model-based deployments work. You define the whole schema in one single spot. Then you take that schema, let's say package it somehow, and then deliver using binaries or PowerShell or whatever, framework. The biggest problem with that is that how exactly you define data inside it, right? So there is no realistic way of defining data and then checking if the data is actually existing in the database. Well, there is, but now if you're trying to check if data exists in a table that has, let's say, 2 billion rows, that's probably not going to go easy, because that's how databases work. And so as opposed to the second option that we have is it's a script-based deployment. So in this case, we have some initial state. It can be an empty database, or we can just suddenly decide, you know what, we have been developing this database for the last 10 years. Well, let's do something different now. So from a certain point, you start to deploy scripts in a certain way. And how it goes, so you develop a new set of changes. It can be one script, can be two scripts, can be whatever. And then you apply those scripts to the database and say, OK, so now this database in the state B. And in order to pertain those changes, in order to track and which exactly state your database in, you track those changes inside the database itself. So each database would have some kind of schema versions table, which would track exactly which script at what time you have run you have executed against that database in order to maintain the integrity. So that helps you to build out some kind of deployment scenario when you have a bunch of files, and now having this version table, you can deploy as many files as you want and ensure that none of them will be executed twice. Why is it important? Because usually when you change the database state, you don't want to do it twice. Let's say you want to add the column called, I don't know, Gary. Why not? And then you run it again, and suddenly your whole deployment fails because, well, you already have a column named Gary in that table. Why this scenario is also viable? Well, you are not dependent on any kind of framework. Your developers can use any kind of framework to develop those scripts. Then once the plain text SQL files that change the state of your database are produced, you can deploy them whenever, however you like. You have full control over the changes, so there is no dynamic generation of the content. In the model-based deployments, you kind of run the black box, and you only hope that it will behave in a certain manner. And I mean, with proper testing, that's probably a normal thing to do. Like when you run it against your test environment and then stage environment, and then you ensure that none of the data has actually been lost, because everyone would check all the tables in the database after the deployment every time, of course. Of course, well, anyone does it any different? I don't know. And then you can switch the framework with your deployments anytime to a different thing, and just continue to roll with it. And let's talk a little bit about the first approach, so the packages. In the Microsoft world, they promote this thing called dacpac. In essence, this is a project in Visual Studio that you develop. Each object would have its own definition stored as a create table statement in SQL or something like that. Then would be like multiple files, one per object, one per table, function, you name it. And then once you hit the build button, there would be a build process that takes all of that schema and packages it all into the dacpac file. Then once you have the dacpac, now you can deploy it elsewhere. So there is a bunch of frameworks that you can use for it, including like native SQL Server Management Studio tool, which is every DBA uses that to manage SQL Server. Then there is a CLI tool called SQL package.exe, which has like a long list of parameters that you can use when you're deploying this stuff. And of course, there is PowerShell, which first of all, there is dacpacs library, which you can add to your runtime, and then using the methods defined in the Microsoft documentation, deploy it using a script. Or you can use DBA tools, which is a PowerShell module, which would present you with a nice function that pretty much does the same. And let me try something different here for a second, because I definitely need to see what I'm doing here. OK, it seems to be working. So what I'm going to do here is I'm going to take a database, existing database, and then create dacpac out of it, and then see what we can do with it. First of all, I'm running containers behind the scenes, so I don't have a Windows authentication. And as such, I need to ensure that I'm authenticated every time I use a command. So for that, I will define a password, then convert it to secure string, then create a credential object, and then use this very peculiar feature of PowerShell called default parameter values. So that allows you, for a certain pattern, to apply certain parameters every time you run it. So in this case, I'm any command that will contain -dba, it will be provided with the SQL credential parameter that will contain this variable here. That way, I will avoid any credential requests for the time of this session. Big thing about, yes?
Just wanted to mention about the default parameter values. If you set them, then they don't override anything if it's in your profile already. So it will break something if you've already got something set for PF2
Yeah, since my profile is pristine, definitely not happening to me. But good thing. First of all, one thing about the dacpac deployments, the options for each deployment is actually a very big list of things that you can control and configure. So let's see what we have for export. So first of all, we want to export our database. So I'm creating this DAC option object, which is pretty much a .NET object. There's not a lot of here because it's just a simple export. One of the important things is you can actually extract data into your dacpac. So let's say if you set that to true and then export your production database, which is like 2 terabytes of data, very soon you will run out of disk space. What else you can do here, and that's what I'm doing, I'm ignoring some of the things inside the database, like permissions, because I don't care about permissions. I don't actually want, and I would probably not recommend you to deploy permissions using that, because every time someone wants access to the database for some reason, well, who would grant permissions to the production database, right? It will override it. So like I said, the golden copy will come and drop all your privileges from all of your users and only leave those that you defined in the Visual Studio. That's not always pleasant, and it takes some time usually to find your proper configuration set. So here I'm just defining the parameters using splatting, and I'm running this export DBA DAC package function to export the database into a dacpac. So now export file would contain some information about how did it all go. And you see it's pretty much gathering all the objects from the database. And this is the name of the database, how long it took, blah, 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 etc., yada, yada. As a result, we have this file in our backup folder. One interesting thing about dacpacs is that, in essence, it's nothing more than a zipper cut. So you can actually go inside and see the XML definition of the schema that you just extracted from a database. I will not go into XML because I don't like XML. As much as I can stay without seeing it, I'll be better off. So now we have this dacpac. So obviously one thing that we can do with it is deploy it back. And let's do that. So here I'm defining the publishing options. And if I check the amount of things here, you would say it's probably not a lot, right? But let's see what's inside the deploy options part. So as you can see, there is plenty of configuration items that you might want to define. And it is really up to your environment what exactly you want. So let's say you can actually prevent the deployment procedure from dropping any objects in your database, including permissions. So if you have a custom table that needs to be in one of your environments, that's what you want to do. You want to define that we're not dropping anything. Now, I'm going to apply some of them. Like, once again, I want to ignore permissions and in all their forms and things like logins, roles, and whatnot. I'm just defining all that stuff. And now I'm ready to publish the database. I'm just providing that option variable, options object, as a parameter to the function call. And as simple as that, you are deploying the whole copy of the database to a different place. So that can be in your pipeline as a deployment scenario. So you have your options defined. You can actually store those options as XML and then specify it as a parameter to the function call. As long as you have the dacpac, it basically makes it very easy to deploy once you have all the parameters right. So here we have this new database, which is an exact copy of the old database that you can see here. Exactly the same set of tables with one small change. It doesn't have any data in it, so it's completely empty. And if that's fine with the way it works for you, That's the way it should be. So what I'm saying is this is like the initial state of your database, right? No data, and then you put some data in it, and then you make the changes to the dacpac, and then now it will persist all the data inside the database and apply only those changes. And now, let's say someone introduced a change, an authorized change to the database. So here I'm just adding a new column to the table using alter table query. And now this column here it is. And if I just try to redeploy this whole thing without changing any code, it will successfully remove this column from the database. And if you check the logs, there's actually the entry. God, I like this software. Is being dropped, data loss could occur. Don't you like it? Yeah, data loss could occur. It's probably like a DBA's nightmare. Well, if you want to put this into a pipeline, this is something that you would want to build. In the Visual Studio Data Tools, you can build the dacpac, or you can use your development environment to export that dacpac. It depends really on the style your organization works. I would probably prefer anyone who works with dacpacs use Visual Studio. Then the dacpac becomes your artifact. So now this artifact you can put in your pipeline, and using the deployment method I just described, you can deploy it to your CI databases, then run the validation tests. Then once that is done, you promote it to the next environment in line, and so on. So there's nothing really special about using that deployment method. It's pretty straightforward, with the exception of the huge list of parameters that you need to define before you do that. Yes?
Does DBA tools have a good pre-run output? I can't remember this.
There is a dash script only parameter to the publish function, which would simply generate a script for you. I believe that's how it's called, but there is definitely this feature. So once you executed the function, it will output the plain text SQL script for you, and then you can review the script and realize, well, is it doing what it needs to do? Unfortunately, there is no real other way of validating that it ran as you want it to run. It can do both things at the same time, but then it will be too late. Okay, so that's dacpacs and packaging. What about the scripts deployments? So like I said, the script-based deployments is a different beast. It uses the things called migrations to alter the state of the database. And usually one script contains modifications to, I don't know, one set of objects or just one simple object. Or maybe it's just everything crammed into one single script. It doesn't really matter. It's the way you prefer it. A lot of frameworks, what they would do, they would track the version of the database in the file name. So let's say there would be version 1.2 _ create table a.sql. And as much as I like the explicitity of it, it's imagine you have, let's say, 10 migrations a week. And then you have 10 scripts you run every week. And the list just continue to grow and grow and grow. And then suddenly, well, you find out, well, what did we deploy like 2 weeks ago? And then suddenly, you need to go into each script and then click through and then figure out what kind of changes did you do. And usually those scripts deployed in the alphabetical order. Some of the frameworks would allow you to do it otherwise. You can deploy script by script. And the main idea here is you deploy each script only once. And that's where the schema versions table comes into play, where the name of the script will be stored. And during the execution, it will run a select statement and then see if this script has already been executed. So until recently, there was no PowerShell solution to this. ever since the beginning of previous year, I've started working on the dbops PowerShell module, and basically this is the task it wants to solve. It is a continuous of deployment of SQL code from the plain text files. The background of this module is, behind the scenes, it uses the dbops library. It is a very popular library for anyone who is familiar with the C# development and database deployments. And it is a great tool, with the only exception that you actually need to write a lot of code to actually deploy the stuff. There is a lot of classes that you need to pull through. There is a lot of options that you need to define. And there is no simple interface that will tell you, OK, click here, 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 or write this command, and you will get the things done. You actually need to go through a lot of code. And this module, the idea behind it was abstraction to this whole dbops framework, or at least the parts that are specifically related to database deployments. As a result, the module was developed to have a flexible configuration module, so you can define your configuration in the runtime. You can define it during the function call. You can have configuration files. It has a build system inside, and that's something that I also spent a lot of time thinking about, and how exactly you can build an artifact similar to what you have in dacpac world, right? You have all these plain text scripts, and somehow I don't believe anyone would want to transfer like 10,000 SQL scripts through the pipeline to deploy them all together. And that's where the build system comes into play. And it's cross-platform, so it supports Windows, Linux, and Mac OS. They're actually being tested on Windows and Linux every time there is a new version. And it works with at least 4, right now, different database types, including, of course, SQL Server and Postgres and even Oracle. And the way it works, let me see. Still here? OK. So first of all, let me run a cleanup real quick, because I'm not sure if everything is pristine. Perfect. Now, first of all, I'll put some attention to the default settings that the module has. You can define a lot of different things to have them by default when you run the function. So let's say the database parameter would tell the function in which database you want to perform the deployment. The SQL instance parameter will tell which server you want to deploy to. Username, password, credentials, it's all that you can define by default when you run the function. And I find it particularly useful for the presentation mode, because I'm going to define these 3 at once and will never look back. So now these 3 parameters are defined, and I will not be specifying them like this. So you see here, this is the first attempt to deploy actually the code. So in this folder, I have a set of scripts that can be deployed to the database. And just for now, I specified exactly on which server I want to do that. But when I run it, basically it will take the bunch of scripts from the folder, you can see it in the logs, and run them one by one in the alphabetical order. It expanded all the folders. It created the journal table, that's your schema versions. And then one by one, it started running the files and adding results to the schema versions. So let's see how it looks like on the database end. So I'm just selecting real quick all the objects that the database has. And you see the first object here, the schema versions. This is where you store your changes. This is where all the deployment log is stored. So let's see what's inside. As you can see, a bunch of script names when it was applied and some ID, which we don't care about. But as long as this table exists and the module knows where to look for it, you have your deployment history. OK, so how exactly you would implement this scenario in the continuous integration, continuous delivery environment? same thing as always. You have your scripts executed. I'm just executing the same set of scripts right now, and there is a bunch of outputs that you can find useful maybe, including like things like where the script came from, what was the deployment log. But what's important, now I'm trying to copy new files into the folder with the scripts. It's just a couple of files. They're stored in a different folder, and they have those names. And you can see the name starts with 1 and 2. That's how you enforce the order of the deployment. Because in database world, there's often objects depending on one another, and you need to ensure that the order is maintained when you're deploying them. So the name here is the way to do that, the name of the file. So I'm just invoking the same exact command here from the same path. And now it figured out, well, we already have the whole damn thing deployed, but we only need, in reality, to deploy these 2 new files that has just been copied to the folder. And it just did that. And as easy as that, as long as you just want to run with plaintext scripts, that works. But that's not necessarily the only thing that you can run it. Let me go back to my presentation. I mentioned build system. So how does that work? Works something like that. There is a deployment package, and basically this package, similar to dacpac, is a zip file. Inside that zip file, there's metadata, there's configuration, and there's deployment scripts. Each package contains builds. Builds is your set of scripts that brings database from state A to state B, and this is a, let's say, finished final state, the version of the database that you want to be in production. So every time you want to deploy a set of scripts, you create a new build with a set of scripts inside, and that build is deployed similar to how the plaintext scripts are deployed. But now, all the builds are encapsulated in a zip file, and that becomes your artifact. So now that artifact can go into your pipeline and can be delivered over the pipeline to your databases. That was the main idea. So as you can see on this particular example, there is schema versions table in each of those databases. And at this particular state, the database has 3 files deployed. And using the schema versions, the deployment mechanism would know that only 3 out of 4 builds needs to be deployed at once. In the empty database, it would be everything at once. In the database that has more advanced version, there would be no need to rerun the old files. And yeah, let's see how that works. In this case, I'm going to use the same set of scripts, and I'm just going to recreate the database I just created using those set of scripts, the old set of scripts. And I'm going to use this new dbo package function, which from the set of scripts in this folder will create a build version 1.0. So let's see what's inside. So this is a zip file, which has some kind of version, last write time, and some builds inside. Let's spice up the things a little bit. Let's add some more files. So from the stored procedures folder, I'm adding more files to the same package. So I'm passing this package as the variable here, and I'm adding new build. So that's going to be our new package. And let's see what's inside. It's pretty much a file object, except it's not, actually. It has builds inside. It has some other properties. It has a module inside incorporated into the zip package. Why? Because, well, if you want to deploy this package on the machine that doesn't have the PowerShell module, and it's your endpoint deployment host, you just probably would want to unzip the zip file and then run the deploy ps1, which will import the module and then deploy all the stuff inside. So that's, I had the, anyone familiar with the Octopus deployment? Yeah, that's what I had in mind when I implemented this thing, because Octopus actually looks for the deploy files inside the zip packages, and that's exactly what you want to use if you run Octopus environment. If you look closer at the object, however, not only it has a bunch of properties here, but it also has a bunch of methods. And more interesting, this is an actual PowerShell class. It's not a C# class, and it's PowerShell class. And what I mean by that is that it was a big struggle to actually implement a PowerShell class that works as you would expect it to work. Why classes? Well, dbop is a .NET library, and it's very extendable, so you can pretty much write your own code and inherit the interfaces that would implement things like logging, things like journaling table, things like whatever. Each part of the solution is replaceable. And if you want customization, let's say I want PowerShell login, right? So I need to implement my own login provider, and for that I need a class. So either I'm writing C# or either I'm writing PowerShell that inherits the interface. So I chose the latter, and I don't really think that was a good idea, to be honest. Like, the struggle is real. If we still have time, like in 15 minutes, I'll get more into why the classes are a very bad idea when you're dealing with that kind of stuff. But as of now, it works, finally. And it has a bunch of methods which can return a different set of objects for you. For example, you can extract a build object and then see what's inside, what kind of version it has, what scripts are inside. And that object actually represents physical object on the disk. It's a zip file, so let's see the get member of the package. It has save method. So if you modified something inside the object, you can actually save it, and it will store the changes to the disk drive. And stuff like that. So you can get all your scripts, and you can see it has byte array property. All the scripts are stored as byte arrays, and then if you call the get content method, you would actually get the content of the script. So this is some type creation stuff. Okay, but enough of that. Let's deploy this bad boy. As you can see, it does pretty much the same thing, except it puts the version in front. And this is where the version 1.0 ends and version 2.0 starts. It does the same exact procedure, but using just one single file, an artifact. And same as always, you can see all your deployment log in the output and the time it took to deploy it. Okay, so when you have multiple environments, it's usually a good idea to have a configuration for those particular environments, the way you want to deploy the stuff. Because, well, otherwise you would have to specify them explicitly in your pipeline. Okay, so you job number 3, you deploy the stuff to server X, and you job number 4, deploy the stuff to server Y. I don't know why, but what you can do here is you can see the configuration inside the package and store it inside the package. Is it a good idea? Maybe not always, but for some of the things, for example, the deployment method, it might be a good idea. Why? Deployment method is how exactly you apply the database scripts. So let's say the deployment fails for some reason. There is a bad code, someone didn't have enough coffee and wrote a crappy SQL code. That happens. But when you run things in the database, every statement usually has its own transaction behind the scenes. Not in every RDBMS though, like SQL Server does that. In Oracle, you need to explicitly commit stuff. But by default in SQL Server, the transactions are explicitly committed on the server end every time you run something. And now, if you're running it with no additional support from the module, the object, the part of the build will be deployed, but the rest of it might be lost, and now you're kind of in the midway. It would be great if the scripts would allow for that situation, so you fixed it, you deployed it, and it just worked. But then not always it's possible. So I prefer to run it in one single transaction, and dbop provides you a great way of wrapping everything you want to deploy into one gigantic transaction. It's usually not a good idea when you're dealing like with huge data changes, like I'm talking like 50 gigabyte huge. But otherwise, for the small iterative changes on some of your objects, usually going to be no problem. So here I'm getting the configuration from the current package and updating it to have a single deployment transaction, single transaction deployment method. And you can see it has updated the data inside the package. The other ways would be you could specify a custom configuration as a hash table and then pass it to the install DBO package as a configuration parameter, and that will override the stuff. But in this case, we have an error. And that's actually to be expected. Why? Well, there is a schema version table before there was, and we actually stored this information in the deployment log table. But here, we did not specify this in this line, and now the module doesn't know where the history is, so it assumes the default table name is schema versions. It looks for that table, there is no such table. Well, it tries to deploy the first script in the line, and it immediately fails because there is already such object in the database. And that's good, because now we can actually have the configuration. So what you can do, you can extract the config from the package, and it's pretty much another object, .NET object, and you can define whichever setting you want. In this case, we're wanting to define the schema versions parameter. We're overriding it with a different value, and we're exporting this file as a JSON. So this is your configuration file. As you can see, it's your good old JSON. And you can actually, interesting thing here is the credential. You can see it's a little bit encrypted, and that's how the PowerShell credentials work. You can actually encrypt them into the base, I think it's base 64. Maybe not. Anyways, the best thing about it is it's only going to work for your user, for the user who made the encryption. So if you try to run it under a different Windows user or on a different machine, it will fail because it doesn't have the keys. And in your case, you can run your CI pipeline and then build the configuration file and then execute it on the same server. And that's the only way the password will not be exposed to anyone who's going to just have access to your files. Now we can use that configuration to install our package. And in this case, we already have it on our database. And it didn't do anything because now it found the proper table and deployed everything perfectly fine. So now sometimes what happens is on the test environment, you have your pipeline, it's working fine, and then suddenly some developer goes and deploys stuff manually. Well, I wanted to test it, right? And now your pipeline is broken because you cannot deploy the same changes twice. So what you can do, you can go into the history table and then input the entries manually. Or you can do it otherwise. So you have your package file somewhere in your pipeline, so you extract it from the pipeline, and you just register it as if it was already deployed. So now, if you try to deploy it again, it is successful because everything is registered as if it's already deployed. So that's the way you fix someone who's being over enthusiastic. Okay, CI. Let's go back to the slides. So when you want to build your pipeline using dbops, this is how it's going to look. First of all, you develop your code, and you do it without any PowerShell involvement, unfortunately, because developers work directly with the database. They create their own objects, they test things, they produce SQL code, which you then build into a package, and that's the process that you run somewhere on the server. You package it together with the rest of the scripts, and then maybe validate it using your CI environment, and then you push it to your environments using the package as the artifact. then once, this is the most important difference between the dacpacs. You need to maintain the history of what you actually deployed, because next time you want to introduce a new set of files to the packaging, you want to have the history of what was already deployed. So let's say we want to implement the same strategy when we have all the scripts in the same folder, and you want to create the package from those scripts, and you put all those scripts in the package. Now, new version comes up, you add the scripts to the same folder, and now you need to have the old package to detect the changes with the current version. So if you have that old package and you can see the upper part of the pipeline, that's where you get the old package from some kind of artifact storage. It doesn't really matter which one it would be. The module provides you with a basic one, which is pretty much a file share where you can store the previous versions of your packages and then extract the version that you like. But it can be Nexus, it can be Artifactory, it can be any kind of DevOps tool that allows you to keep those packages. And then using the previous version, you integrate the scripts into it. And that's exactly how it works in real life. So let me go back to the CI functionality. We have like 4 minutes left. So now, I'm just going to quickly run the CI/CD pipeline as if it was inside some kind of deployment tool. So I don't have any files here in this folder. I'm going to use this command here to invoke the package CI, and it will dynamically detect all the new files from this folder and create a package version 0.5. Now we have this package version 0.5.1 with the single build. Now I'm going to create a repository and store this package in this repository using publish dbo package artifact. So now this file is stored in the current version inside the repository. And once again, I'm adding new files to the folder with the scripts, and I run the same command again. Now it detects the old version of the package, and it introduces changes to it by deploying a new version. And that's what's inside. You can see that the build 0.1 has this kind of scripts, and build 0.2 have only stored procedures. And then you can pretty much do it manually if you want, using the add dbo build with all the parameters specified and type equals new. You can store it once again in the package artifact repository, and in essence it's just a simple folder with all your packages, current version, previous versions, and you can extract it, and you can deploy it, and even send an email notification, if you wish. All right, so as a bonus, this is what you would do if you want to run it against Postgres. So I'm just removing all the default settings that I just defined, creating a new credentials for Postgres, and now I'm connecting to the Postgres server and running query against it. So you can see it's a Postgres 11.2, and you can even connect to it in the interactive mode, and then do select star from, no, let's do something simple. Here we go. Okay, so that's pretty much all what I have to say. Any questions? Thank you very much.